Hello students, welcome to class 11 physics. In this video we are going to learn about the work energy theorem. But before proceeding to the topic, let us see first the definition of work and the kinetic energy. So work, we know that work is force into displacement. So its definition can be written as the product of the magnitude of the force and displacement during which the force x is called the work. That is, work equals to force into displacement. And we had already seen the conditions for the work, in which case it is 0, in which case work is positive, and in which case work is negative. So if force and displacement are in the same direction, the work done is positive. If force and displacement they are in opposite direction, the work done is negative. And if force is perpendicular to the displacement, the work done is 0. Now let us see the kinetic energy. First of all, energy is the capacity of doing the work. And we know mainly two types of energy, that is kinetic energy and potential energy. Potential energy, that is energy possessed by the body due to its position, is called as the potential energy. Kinetic energy is the energy possessed by a body by virtue of its motion, is known as the kinetic energy. Hence, if a body moving with more speed would have more kinetic energy compared to the kinetic energy of the same body moving with comparatively lesser speed. And we know kinetic energy K equals to half mv square. So by this formula also we can write the definition, that is half of the product of the mass of the body and the square of the velocity of the body. So we can see here the second definition, half of the product of the mass of a body and the square of its velocity is defined as the kinetic energy of the body. That is K equals to half mv square, where m is mass of the body and v is the velocity or speed of the body. So first you note down this definition, then we will proceed with the topic. Now let us see the work energy theorem. For straight line motion, that is for the object moving in one dimension, if body is moving with initial velocity u and constant acceleration a, it acquired velocity v with displacement s, then from the third equation of motion we can write v square minus u square equals to 2as. That is, here we are using the third kinematic equation. V square minus u square equals to 2as. Here v is the final velocity of the object, u is the initial velocity of the object, a is the acceleration and s is the displacement. In each equation we will be multiplying both the sides by m by 2. So it will be m by 2 v square minus u square equals to m by 2 into 2as. Here 2 gets cancelled, so on the right hand side we will be having mas. Now opening up this bracket we will be getting half mv square minus half mu square. So we can see this equation, half mv square equals to half mu square equals to mas. So mv square, that is half mv square, that is kinetic energy, and here v is final velocity, so we can write kf, final kinetic energy, minus here u is the initial velocity, so here half mu square, that can be written as initial kinetic energy, so kf minus ki. Here ma is nothing but force, so force into s, that is force into displacement. Now for the motion in 3 dimension. Again using the kinematic equation, third kinematic equation, that is v square minus u square equals to 2ad. Again multiplying both the sides by m by 2, we will be getting the equation half mv square minus half mu square equals to ma dot t. Here mass into acceleration is nothing but force dot t. Now the left hand side is the change in the kinetic energy of the body, because we have seen that half mv square, that is kf, minus half mu square, that is ki, initial kinetic energy. So the right hand is the multiplication of force and displacement. It is known as work and it is denoted by W. So over here, instead of this, we can write it as W. So this equation can be written as Kf minus Ki equals to W. Kf minus Ki, that is delta K, change in kinetic energy, equals to W. So this is the work energy theorem. Delta K equals to W, this relation is known as the work energy theorem. So students, you may note down this theory.